All right. So, good morning, good afternoon, and good evening to our viewers from all around the world. My name is Anish, and thanks so much for joining us for this live code with AppSec Engineer. So, I'm joined by Vishnu Prasad, our DevSecOps lead at AppSec Engineer, and he will be presenting a very interesting lab from an upcoming course that we will be presenting at Black Hat Asia. Hi, Vishnu.
Hi Anish.
So,
Yeah.
can you tell us a little bit about what this
We'll
lab
just
is going to be?
right. There is one security flaw which is present in almost applications. Where there are wide chances of having that application vulnerability in applications called SSRF, and there is a library by name VisiPrint. This is a library which is a victim of SSRF flaw, and an application which is having this VisiPrint library to parse the data from HTML format to PDF format. While the parsing is happening, the SSRF redirection will happen. And how we are going to leverage this vulnerability to compromise one of the services of AWS, that is ECR, Elastic Container Registry, where we have our containers. We're going to compromise this with the help of this flaw. We're going to first leverage this flaw, fetch some credentials, and based on the credentials, we're going to perform further attack. Basically, we're going to compromise the entire registry, and we're going to trojanize an image container inside that registry, and we're going to get a shell access. We're going to get the persistent shell access so that we can interact with application as a backdoor by an attacker. We're going to simulate this and see in this lab today.
Nice. That's great. So, just to remind you folks, this is going to be a full length, it's a 2 day course that Vishnu will be presenting himself at Black Hat Asia in Singapore between April 16th and 17th. So, that is something you can look forward to. We'll be dropping a link in the description below to actually register for that event. So, you can go do that right after this live code. All right, Vishnu, you can take it ahead.
Sure. Thank you, Anish. First, I'm going to discuss few theoretical concepts, what's happening, and later we're going to jump into hands-on that's happening in the labs. I'll just share my screen. You can confirm. I hope you can see my screen, Anish.
Yep. It's all
All right. So when it comes to compromising AWS ECR, first we're going to see a flaw with a library which is having an SSRF flaw, that is VisiPrint SSRF. Then we're going to see how this library is having the vulnerability that is interacting with the payload that has been submitted by an attacker, and what is the payload that is submitted by an attacker, and what are the consequences of this particular SSRF flaw that is present in this library that we are going to use for compromising the Elastic Container Registry ECR of our AWS instance. So this PDF generation library is used to generate or render the HTML CSS content to PDF. It's going to convert HTML and the CSS content to PDF in one of the functionalities of the application that has been deployed in one of the containers in a ECR registry in our AWS instance. So once this library gets compromised, eventually we can compromise the ECR instance and also trojanize the containers, etc. We're going to see in this attack session. So at first we're going to see how the SSRF works. SSRF is a typical vulnerability where the redirection happens by shipping sensitive information to an attacker machine without any URL validation. There will be a tamper of the URL, which is forged URL, and the redirection happens without even validating whether the URL is of our application instance or from an attacker source. So this flaw is present in VisiPrint library that we are going to leverage for. In this, you can see that there is an attacker that is crafting a URL saying 169.254.169.254/metadata, which will return the metadata of an instance of any services that are hosted upon with the help in the response that is fetched from a web application. Once this redirection happens, web application will give the response to the attacker with all the metadata information that is required for an attacker to perform further level of attacks. Right. One such library is that VisiPrint, which is an SSRF which is a SSRF vulnerable library, which is VisiPrint SSRF, where attacker can craft a payload in a link tag There is a link tag that can be added as a payload. Then when the parsing of the HTML content to PDF happens, this link tag will get executed and the credentials will get harvested inside your PDF library or the PDF file itself. We're going to see in the lab later. So when it comes to VisiPrint SSRF, attacker is going to add a payload here and add it to the PDF generator in the form of normal HTML context. While parsing that HTML context, this payload, the link tag will get executed by performing the server-side request forgery. The redirection happens, and all the details related to all the details that are fetched by that particular redirection is stored in this PDF file that is generated. And we can fetch that PDF file and obtain that sensitive information with the help of this PDF file. We're going to see in the lab. So in this example, today's ECR compromise example, we're going to see there is an ECR registry in our AWS instance, which is going to pull the containers to the EC2 instance. It is a server box which is pulling some containers from our EC2 registry, which is hosted with a normal application, which is having an SSRF flaw. So by leveraging this SSRF flaw, one can fetch the container from the ECR registry and trojanize that container and again publish to ECR registry. And whenever that trojanized image is been again pulled by that EC2 instance, then we will get a reversal access to this EC2 instance, eventually gaining access to the complete server box itself and also the application hosted inside that server box. So this is our attack pattern for today that we are going to see in our ECR container registry attack. So let us switch to our lab instance. For saving some time, I have brought up the application. I have started application and make it up and running. First, we're going to run this ACCTL in our sandbox environment. First, we can click here, and once the server box is provisioned, we're going to get a sandbox environment here. In this sandbox environment, we're going to fetch the credentials of a sandbox that is provisioned for this lab. Every user will get a dedicated sandbox environment, a disposable sandbox AWS account, where you can perform all the hands-on labs. You can execute all the commands of the labs, and you can dispose that account so that your AWS account is not tampered or been compromised of. So at first, I'm going to run this ACCTL command so that this will generate the sandbox creds for me with the AWS access key and secret key. Later, we're going to initiate a Terraform script where the Terraform will deploy all the services that is required for the application up and running. In this directory, we have our Terraform script. I'll just quickly walk through the Terraform script here. This is our Terraform script, which will provision all the services inside your AWS environment. It might be an ECR, it might be a container, or it might be an EC2 instance. Everything will be provisioned by this Terraform scripts here. So when we go to the script.sh file, we can see here, we are going to clone a Docker container that has been already hosted in our Docker Hub of our official Docker Hub. Then we're going to trojanize this in our further sequence of attack. Then we are going to publish again to ECR so that whenever a EC2 instance pulls this container from the ECR, whenever the EC2 instance pulls this container from the ECR, this gets compromised. So this is a Terraform script that's actually provisioning all your services that is required to execute this lab. Right. Now, after this Terraform apply is been approved, you're going to see all the services that are up and running, and you can access this application by the domain here. There will be a EC2 instance domain that will be given as a Terraform output. Then this EC2 instance followed by 5000 is a port that is used to the port that is in which the application is running on. So once the application is up and running, we're going to start the attack, how it is performed. At first, we're going to sign up to this portal. There is a portal here which is having basic operations like login and sign up activity. At first, we're going to sign up with some basic information so that we can use that information to log in later. Just I'm giving first name, last name, email, and a password to sign up. And in the remarks section, I'm going to add this payload here. So you can see this is the same 192.169.254, 192.169.254 metadata URL that I discussed before. This is the same URL that I'm adding it in the link tag with the help of href. So whenever this data, this first name, last name details are getting passed, this redirection happens with the help of SSRF flaw that is present in VZprint library, then this metadata information is added in the PDF that is generated. Now I'm going to sign up with this payload here that is added by an attacker. Now that I have signed up, I'm going to sign in with the credentials that I've already created for. Just my email ID and my password that I gave during my sign up activity. I'm going to log in here. You can see there is a generate PDF option here. Once I click on generate PDF, just my email ID and first name, last name is been parsed and a PDF is generated, which I'm going to download here. To further analyze this PDF library, I'm going to upload this to my sandbox environment. This is a typical PDF library. Just by viewing this PDF library, you cannot see any sensitive information as such that you saw. But when we do the binary walk, I mean, when we explore further with this PDF library, we can see the information that is being fetched by. We'll perform the binary walk of this PDF library, and then we will see what are the information that is being provided by the SSRF flaw that is present in the VZprint library. So I'm going to binary walk this PDF here, which will generate a dedicated folder under this PDF file name, and all the binary that is being fetched by this PDF will be stored over there. You can see once the binary walk is done, you can see there is a folder created for this PDF file. In this, if you can directly switch to this particular binary that is been extracted by this PDF file, you can see there is an access key, secret key, and token. That is, there is an access key, secret key, and a token of the account that is used to deploy all the services here. Your EC2 instance and your ECR instance is provisioned by these credentials, and these credentials are harvested by metadata with the VZprint flaw. Now we are going to use these details, and we are going to compromise the container that is present in ECR. Right. Now let us proceed our further attack. At first, we are going to see the caller identity here. At first, before even we compromise the system, you can see that is currently the user is AppSec engineer here, which is of a sandbox that we provision. But we will store this. But we will add these credentials for environment variable and again execute this command and see to which user that particular instance will get switched, or the AWS CLI will get switched for. I'm going to add this credentials as environment variable for our AWS CLI to get I'm going to copy the secret token after access key ID. At last, I'm going to fetch the session token and store it in a environment variable. Right. Now all these environment variables are set. Now again, we are going to see the caller identity by our AWS CLI. At first, we saw an AppSec engineer identity, but here the role has changed to a particular identity here, which is the credentials that is been harvested by VZprint. Right. Now we're going to do further attack by compromising our ECR instance. So let us describe the ECR instance. Anyway, we have the credentials now, and see which is the container present in ECR instance. You can see there is a repository name by AppSec engineer and the customer app. This is application that we are going to this is a container that we are going to fetch, and in this repo there is a container. We're going to fetch it and trojanize it. So we're going to store this repo URI in an environment variable with the help of this CLI command here, which is present in US West 2. Now that the repository URI is set as an variable here, we're going to log in. Now that we have successfully logged into our ECR, we're going to pull the container that we are going to Trojanize it for further attack. Now that we are pulling the container first to our local machine, and with the help of a Docker scan, which is used to Trojanize Docker containers and test the Docker containers for vulnerabilities, we are going to use the Docker scan tool to Trojanize the container that we are cloning now. It takes few minutes to extract completely. Yes, now that the extraction is completed, we're going to execute this Docker scan image with the help of setting up the server IP as a reversal access with the port 1337. We're going to set our lab instance server IP and port 1337 to be accessed as a reversal with the help of Docker scan, which is going to Trojanize the AC1 Flask container. It takes few minutes to complete. Yeah. Now that uh, the container is completely pulled, we're going to Trojanize this. Docker scan has started the analyzing of the container, and it is completely Trojanized. Now you can see that with our server IP, that is 35.219.150.39 is our server IP of our sandbox environment, and 1337 is the port. By this IP and port, the reversal is possible. Now that the container is Trojanized, we are going to remove the previous container that was cloned, and we are going to load this into a tar file. The complete container is been loaded as a tar file, and we are going to upload again back to the ECR later. Now we're going to load it to ECR by pushing it to the ECR. Now the vulnerable container, which is Trojanized, is stored in the ECR now. Next, we are going to perform the further attack. In the next tab, I'm just going to add a listener here with 1337. You have noticed that 1337 was the port that was used to Trojanize the container. In a new terminal, I'm going to open a listener, a netcat listener. All right, now we're going to switch to the ACR, our EC2 instance, our server box, and we are going to clone that containerized vulnerable container that has been Trojanized few steps before. This is a permission key that is used to SSH the EC2 instance. Now I'm going to perform the SSH here. Just we need to replace EC2 DNS with the DNS of our EC2 instance. You can take it from here. Just remove this http:// yes. Now that we have SSH into our server box, just we're going to get the root access by doing sudo su. And now I'm going to kill the previous container that's already running, and I'll stop it. Okay. Before we doing it, again I'm going to fetch the repository URI of our ECR here to clone the newer Trojanized container. Again, I'm going to log into our ECR here. Anyway, we have our credentials. Right, now I'm going to pull the latest Trojanized container here, which is containerized in our previous steps. Right, now I'm going to stop the existing container, which is the safer version before, and I'm going to run the vulnerable version. Just do docker ps, and there is a running container here. Just do docker stop with the container id. This will stop the previous one, and you can bring up this newer container that has been cloned from our ECR. Yes, now that this is running, you can see that we have got the reverse shell for this EC2 instance. That is a persistent reverse shell, where you can, whenever the container is up and running, an attacker will get a persistent shell. By this, an attacker can do credential harvesting, sensitive information disclosure, source code disclosure, credential disclosure, and whatnot. These are all the further attacks that an attacker can do. You can see you can modify the Docker file as well and add malicious libraries to improvise this attack further. This is how our ECR instance got compromised because of one flaw, one library, which is a major part of a supply chain. So being aware about the supply chain issues is most important, because while choosing your libraries, you need to make sure that that is vulnerable free, and there is a regular patches and maintenance that is happening in that particular libraries, so that it is not having any vulnerabilities. Because of VisiPrint library having a vulnerability which resulted in the sequence of attacks, and by one vulnerable library we were able to compromise one of the major services of our AWS cloud premise itself. Yeah, Anish, this is how we can compromise the AWS ECR.
Awesome. Thanks so much, Vishnu. Thanks so much for that excellent presentation. That was a great showing. So, guys, just want to remind you that this exciting lab is just a tiny slice of what you'll be experiencing on the entire 2-day course, which is attacking the application supply chain. This is a full course that will be available in Black Hat Asia in Singapore on April 16th to 17th. So it's going to be a 2-day course filled with a lot of hands-on labs, and it's a purely offense and attack-based course. So it's going to be something that we introduced it just last year or a couple of years ago. So it's a very new course, and we're constantly evolving it. So these are supply chain attacks that you've never seen before, and these are things that are pretty much at the forefront of the security landscape. So definitely get registered for that. The link will be in the description. You can get registered for that before the seats run out. Less than 2 weeks left. Remember that. So please check it out, and we'll see you in Singapore for Black Hat Asia. See you then. Bye-bye.